In this video, I want to talk about the power reducing formulas, and I have given them to you here. Again, in this video, I'm not going to go through the derivation from them. You can read through your book for that or look them up. They're basically derived from formulas we already know again. So the first two formulas are derived from the double angle formulas with cosine of 2 theta. And then the tangent squared one uses the idea that tangent is sine over cosine. So it uses that as well to derive that one. So I'll let you check those out, and let's just go ahead and do an example with them. So we're going to write an equivalent expression for cosine to the 4th power of x that does not contain powers of the trig function. And I'm going to just pause this video because you can see my dog here is trying to say hi to us. So give me 1 second. All right, let's keep going. That was my dog Griffin who just came to say hi, so he's off now. And what we're going to do in this example is we're going to write an equivalent expression for cosine x to the 4th power that does not contain powers of trig functions greater than 1. So meaning we don't want squares, cubes, fourths, or anything like that. We want to get it down without those higher powers. And obviously this is going to take a lot of algebraic manipulation, and one of the things we're going to use is one of our power reducing formulas. Notice it's called power reducing formulas because it's taking that power and bringing it down, right? You're going from squares here to just a power of 1. So if you want to rewrite an expression without a higher power, we definitely want to use that power reducing formula to help us get rid of that higher power. So the first thing I'm going to note, right, is cosine 4x really means cosine x to the 4th power, just to kind of remind you that. So it just means cosine to the 4th power here. And you can note that this is the same thing as cosine x squared, right? So 2 times 2 is 4. So I'm going to start by using cosine squared x squared first. So I haven't changed anything. I've just broken this down a little bit into a square being squared. And the reason I did that is because now with this piece here, I can go ahead and use my power reducing formula on that inside piece. But don't forget there is a square on the outside, so that whole thing is being squared here. And we're going to go ahead and, sorry, this should be an x, not a theta. And we're going to go ahead and actually square that and multiply it out. So if you can do it in your head, great. If you find that you're making mistakes, then take a second and go ahead and write this out. And we're going to go ahead and FOIL it. Now for the denominator, it's just going to be 4, right? So I'm not going to worry about the denominator. 2 times 2 is 4. And I'm going to worry about FOILing the numerator. So I have 1 times 1 is 1. 1 times cosine 2x is cosine 2x. On the inside, same thing. 1 times cosine 2x. And then on the end there, I have cosine 2x times cosine 2x. So we're going to have a square there. All right, so to clean this up a little bit, I did put these together. So 1 here and 1 here makes 2. And now this looks better, right? So I don't have any higher powers here or here or here, but I do still have a square there. So I am going to go a little bit further. One other thing I'm going to do is I'm going to just break this down, this fraction. So I'm going to rewrite it as 1/4. And then I'm going to do this fraction here. Now 2 over 4 would be 1/2. And then here I have 1/4. Be careful when simplifying fractions here. You're not simplifying this 2x, you're doing the outside ones, because this is being plugged in to the cosine function. So we're not touching the inside of that when we simplify with our fractions. So what I'm going to do now again is I'm going to apply again a formula to this piece right here. So you just want to be careful there. We're going to go ahead and apply that again. And I do need some more paper. So this is my formula I'm going to use. Just rewriting the beginning part. Again, this 1/4 is just going to kind of hang out, and I'm going to go ahead and use my power reducing formula there. And it's 1 plus cosine Now it's cosine 2 theta. So in this case, this 2x is like my theta. So I'm actually multiplying that twice. And it's all over 2. And again, that extra 2 comes from the fact that in my formula, there is a 2 there being multiplied. So whatever your theta is, you're multiplying it by 2, which we did here in our first step, right? We went from x to 2x. But now I got to do it again. So that's why I'm going to go ahead and multiply by that 2x and multiply it by 2 one more time. Now here, 1/4 times, this would be like a 1/2, that 2's in the denominator would just become 1/8. And then 1 plus cosine of 4x. I'm going to go ahead and distribute that 1/8. So it's going to be 1/8 times 1 is 1/8. And then 1/8 times cosine of 4x here. Again, you're not canceling anything on the inside there, just any values out front. So I'm not going to cancel the 4 and the 8. I have to leave that alone. And then the last thing I'm going to do is I can put these together. You need some common denominators, right? 1/4 plus 1/8 is the same thing as 2/8 plus 1/8, just 3/8, using common denominators. And finally, we are done. We have reduced all of our powers there. Again, it's not really a nice formula. We weren't saying to simplify it to the best formula. We were asking to rewrite it without those powers. So we have done that. There's no more powers here. And again, you don't have to write parentheses, but just remember that this is sort of being plugged into cosine, right? So it's not on the outside. It's cosine being evaluated at 4x or at 2x. This is as clean as we can get it. I don't really want to use my double angle formulas here. I think that will start to get too messy. So I'm going to leave it like this. And this would be our final result.